All right, part 2 of atoms and elements, elements. So, elements, the definition of an element is a substance that cannot be broken down into simpler substances by chemical means. Meaning, you can get down to one atom of an element. So, all elements, remember, everything is made up of atoms. The type of atom the type of element that an atom is determined by the number of protons. And once you get down to one atom, that's the smallest you can go and still be an element. Beyond that, you're getting into subatomic particles. So an element is composed of atoms that have the same number of protons in their nucleus. By definition, that atomic number, which in the image here we have magnesium, atomic number 12, that atomic number is the number of protons that that element has. It can have different numbers of electrons, those are called ions. It can have different number of neutrons, those are called isotopes, but it is always, always, always going to have 12 protons. So, like I just said, every element has a unique atomic number. It indicates the total number of protons in the nucleus of the atom. So, and you will be doing practice with this, if I gave you a periodic table and I said, tell me the element that has 20 protons in its nucleus, you could look for atomic number 20, and you'd be able to tell me that calcium is going to be what that atom is. Normal atoms are electrically neutral. Same number of protons as electrons. We are only going to be looking at neutral atoms in this course. If that number doesn't match up, if it has more or less electrons, it has an electric charge, we call that an ion. We're not going to be looking at ions this year. So for the focus of our course, protons and electrons are always going to be equal. So the atomic number is not only going to give you the number of protons, but it's also going to give you the amount of electrons since we're looking at normal atoms here. The symbol is the abbreviation. So every element is going to have an abbreviation. We always do a capital and a lowercase. If it's only one letter, we just do a capital. That's just like capitalizing the first word of a sentence. It's just how we do it. So every element is abbreviated using a unique symbol of one or two letters. Again, the first letter is always capitalized. If there's a second, it's going to be lowercase. Some are based on other languages. So you'll notice as we go through this, some of these are weird, like gold is AU, silver is AG, iron is FE. Those are derived from different languages, and that's why the letters don't match up with what that element name is in English. Element name, that's pretty self-explanatory. Every element has a name. Many element names are very old and are based on other languages. Some of the newer elements, the ones that end in like ium, are a lot of times those are named after someone. So chlorine is named after chloros, the Greek word for yellowish green. So a lot of these element names come from something, even if it doesn't make sense in English. Newly discovered elements are named by the discoverer, but they also must be approved by an international committee. So a lot of times these new elements are used to honor people, like Einsteinium was named in honor of Einstein. Atomic mass is the one where we're going to be doing some math. And I know we love doing math. I'm going to ask you to do the really, really difficult math of subtraction in this class. So atomic mass is the number of protons and neutrons in the nucleus in an atom. Every proton and neutron has a mass of 1 AMU. So protons plus neutrons equals atomic mass. We already know the number of protons because that's the atomic number. So if we take the total number of protons and neutrons, subtract the number of protons, that leaves us with the number of neutrons. So atomic mass minus atomic number gives us the number of neutrons that an element has. Again, electrons do not count towards the mass because they're so tiny. We just disregard them when calculating mass. So the reason why it's a decimal point. That does not mean we have a decimal point of a neutron. What that means is that elements exist in different forms, different isotopes. An isotope just means different number of neutrons. That atomic mass is going to be the average of all of those isotopes. So 24.305 would be the average atomic mass of magnesium. We're going to go with that average and round it to the nearest whole number because we cannot have a decimal point of a subatomic particle. So for example, here, 24.305, the closest whole number is 24. So that's what we would use. So to calculate the neutrons in magnesium, we'd have that 24. Remember, we're always going to round to that nearest whole number. We don't have a decimal point of a neutron. So 24 is the total number of protons and neutrons. If we take away the number of protons, which is 12, we're left with neutrons. So 24 minus 12 is 12 neutrons. The number of neutrons is not always going to match up. Sometimes it will, sometimes it won't. So for calculating protons, electrons, and neutrons, all you do is you have your atomic square with all this information on it. The atomic number, which in this case is 12, gives you protons and electrons. Super easy. So we have 12 protons, 12 electrons. And then neutrons, we do our math. Atomic mass, 24.305. We round it to 24. We subtract the atomic number, which is the number of protons. That gives us the number of neutrons. We're going to be doing a lot of practice with that in class. And with that, your notes should be done, and I will see you guys tomorrow.